𝗬𝗲 𝗵𝗶, who is our alumni and also a reputed geotechnical consultant with an experience in India and abroad. He is currently one of the managing directors of Cengrs. So please join me in having 𝗬𝗲 𝗵𝗶.
Thank you very much, Dr. Sumit. I'm greatly honored that you have invited me to talk at this occasion here. This topic which I'm going to talk on is skill, experience, and judgment in geotechnical engineering. I will be talking with special reference to geotechnical investigations because that's what I have been doing all these years since I passed out from IIT. So as you know, geotechnical engineering is everywhere, and it is the support discipline for all civil engineering disciplines. Whether you're talking about structural engineering, earthquake engineering, waste treatment, transportation, urban infrastructure, it could be heavy industry, water management, hill area development, everything requires geotechnical engineering. And you will see it in every facet of life. But today we are talking about building big. And when you want to build big, then geotechnical engineering becomes very important. So there is talk about smart cities. Infrastructure has gone to a new level, particularly industrial plants, power plants, refineries, tall buildings. We are now don't bat an eyelid of 50 to 70, 80 stories buildings, metro and railways and road bridges. Even culture, you have these huge tall statues coming up, all kinds of buildings, temples. We had the 𝗬𝗲𝗶𝗵𝗵 𝗬𝗲𝗵𝗵. So much activities are going on. And the future, I would say it is without any limits. So geotechnical engineering is the basic service for all kind of activities. So what does the modern age geotechnical engineer, what kind of skills does he have to possess? Obviously has to be multidisciplinary skills. Considering geotechnical engineering as a subsect of just civil engineering is no longer sufficient, because narrow perspectives could stifle progress, it can stifle innovation. So you have to widen your perspective, your understanding, interact with professionals of different disciplines, and link geotechnical engineering with other geosciences like geology, mining, environmental and earthquake engineering. That becomes very essential, and not just other geosciences, other engineering disciplines. Electrical, mechanical, chemical engineering, you have to understand these to understand the tolerances of various machines, environmental impact. In fact, when we were working on the Ram temple, we had to understand some of the religious requirements of the temple to be able to do the geotechnical engineering right. For example, they said that you cannot use steel in the structure. But you know, modern civil engineering is about reinforced concrete. And if you can't use steel, then the whole thinking has to change. So you have to acquire that kind of a knowledge and skills for globalization. So that is the new paradigm for all engineers today. The challenge, of course, is how to navigate between these different bodies of knowledge. What are the skills that you need to acquire? So we have to go beyond the classical geotechnical engineering, the classical simplistic concepts, and take on new challenges. Environmental engineering, ground improvement, engineered barriers, rock mass behavior, sustainability, energy production. We are doing so much work on renewable energy and projects like solar energy and wind energy. The geotechnical requirements are very much different from what we are used to. And of course, when you talk about theoretical versus practical research, that has been the topic of discussion here. Computers, of course, they have revolutionized theory, but and solutions which were not easily possible, you can get it with the click of the mouse. But as Professor 𝗬𝗲 said, observational method, use of engineering judgment should not take a back seat. It is very important. Field monitoring and instrumentation, that's what will provide your understanding of soil behavior. So input the field observations into the theoretical model, and then you develop your solution by back calculating the design parameters and revise the design based on the observations. So then you can validate your design based on real-time data. So research and development should address non-quantifiable factors, something you cannot put a number to. And of course, the field experience of the engineer becomes most important. So your engineering solution has to be reliable, economical, and practical, but most important, it has to be amenable to speedy construction so that the performance of the structure is as designed. So now we talk about experience. What does the experienced geotechnical engineer, he would consider field studies, success stories, and failures. Failures are more important than success stories in trying to figure out how to solve a particular problem. So you have to be flexible yet systematic, have the proper choice of investigation techniques, and then select your suitable analysis methodology. Most important, sound engineering judgment. So when we are talking about having the right kind of geotechnical data, I am very much, I like this geotechnical input pyramid from bronze, silver, gold, and platinum. As you move up this pyramid, your factor of ignorance reduces. I don't look that much on factor of safety, should be more, but the factor of ignorance has to reduce. Your reliability of the design has to be enhanced so that you can reduce the cost of the foundation and the construction time, but yet minimize the possibility of failure. So if you will look at a geotechnical investigation, move from a bronze level to a platinum level, so the investigation would be a very limited investigation here, but as you go towards the platinum, gold and platinum levels, you have a lot of borehole in situ tests, advanced laboratory testing, and all that. And here, the geotechnical engineer in a gold or platinum level would be an experienced expert. Design parameters at a bronze level is guessed, whereas you have site-specific design parameters. So the analysis is also, almost none at the bronze level, is just throw some numbers. To advanced numerical modeling, maybe design rules are also thumb rules. You have optimized serviceability criteria. The foundations, of course, if you have a gold level or platinum level, you have optimized, practical, easy to build, saves not just money, also saves you time. Risk level goes down here, but the cost, of course, of the investigation would be much higher if you were doing gold or platinum level investigation. But always you spend a little bit more money, and what you save on the foundation cost and time is much more. So what I would advise is that you move towards gold and platinum levels of investigation. Now, if you are doing SPT, let's measure the energy transfer for a greater reliability. Move on to CPT, CPTU, dialitometer, pressure meter, vane shear tests for better assessment of the soil characteristics. Use of geophysical testing, advanced sampling and laboratory testing methods, remote data acquisition. So all that is coming now. So in situ testing, that's the most important thing, that if you have field instrumentation, you have in situ tests, you can have a better understanding of the behavior and effective adoption of advanced technologies. You will be able to get better solutions. So what kind of new available techniques are there? You have very good drilling rigs available. SPT energy measurement standardizes to 60% energy transfer, so you are able to correct the uncertainty in the SPT measurement. There is the CPTU, seismic CPT, pressure meter, footing load test, much better than plate load test. Geophysical tests, there are a whole lot of tests which are available nowadays, which can be very useful for your design. So here are some drilling rigs. These kind of drilling rigs can, increase your productivity on sites much faster, get you better quality samples. SPT energy measurement. So you have an instrumented rod here, which is inserted here. This is a auto trip hammer. So you measure your energy transfer. So this is, as I told you, a 0.6 meter rod with instrumentation. 2 accelerometers are bolted, and also you have sensors to measure the stresses, so strain gauges. So you can then measure this SPT energy transfer. CPTU is now very common. Here, this is a crawler-mounted CPT rig. This uses anchors. The CPTU, you have a pore pressure measuring sensor also at this thing. So these are the kind of cones which are being used. Typical CPTU results. So you can get a very good idea of the soil type also. The pore water pressure is being measured here. Seismic CPT, here you have 2 sensors which are measuring so this is the top sensor and the bottom sensor. So the electronics there, you are able to measure the shear wave velocities. This is the seismic CPT in progress at one of our sites. So I won't go into all the details of the advantages, but you can see speed, continuous profiling, increased productivity, a lot of saving in time as well as cost. Of course, the additional sensors like to measure shear wave velocity, electrical resistivity, thermal resistivity, all that is possible. You get a large volume of data. Soils that are difficult to sample, you can get good data from there. So instead of trying to collect undisturbed samples of loose sand or soft clays, CPT can give you the data. Minimal surface disturbance because you are not having any drill cuttings generated. Higher bearing capacities and pile capacities can be justified by the CPT. Of course, every test has its limitations, one of them being that no sample is obtained. It's a little complex because you need the field technician who goes to the site needs to understand how to operate a computer. Availability in India is still limited. Of course, rock and strata containing boulders, you cannot use CPT. Come to the pressure meter, the dilatometer, all this is being done today. The Maynard pressure meter, you see the photograph here. So this is done in pre-bored holes. So you get all these parameters from the CPT. This is the pressure meter test in progress. Engineering analysis, of course, advanced analysis, reliability and risk assessment, value engineering, using a probabilistic approach. Centrifuge modeling is also being done nowadays. Of course, numerical analysis is very popular. Let's try to move towards advanced analysis too. But most important thing in engineering analysis tools is your engineering judgment. The pet cliche being used by many people, geotechnical engineering is a science, but it's practice and art. So what is that art here? So you have data. You must have good quality data to be able to take your decisions. You have referred to standards, technical specifications to be able to interpret the data. You should have that kind of right experience to use all this for an engineering judgment so that you can take the right decisions. So most important, of course, is to remove the disconnect between research and practice. That has been the discussion. So if this is the kind of samples that are being collected on the site, then all kinds of advanced finite element analysis is useless. So I'll talk a little bit more about engineering judgment. So the judgment has to be based on knowledge and experience of that engineer to be able to provide a reasonable solution. So years of experience and resources are available. You may be able to make a judicious situation, but of course one shoe does not fit all. So you have to be able to understand this concept of how the way it has to flow. You analyze the data, you make the predictions, and you should be able to take the right decisions so that you have a successful project. You should be ready to go beyond the codal provisions and out of the textbook situations to be able to work out the right kind of a solution. So to be able to realize this on the ground, the design, the geotechnical engineer has to be involved throughout the project, including the construction monitoring, site visits, etc. Regular design meetings, site meetings, design iterations, all QA/QC reports, foundation load tests, pile integrity tests, etc. must be reviewed by the geotechnical engineer. Just don't throw that pile of reports in the dustbin, use it. So mandatory instrumentation with proper data logging for important structures. This is now being talked about in the country, but not yet very effectively implemented. But what I'd like to show you, if this is the quality of piles, no matter how conservative your design is, the pile is never going to behave as you design it. So let's talk about the future. I first go to the investigations of the future has to be technology oriented, increased use of computers and softwares, remote data acquisition, superior quality of sampling and laboratory testing technologies that are more reliable, CPT, pressure meter, dilatometer. Hopefully SPT will die its natural death, but as long as SPT is alive, please measure the energy transfer. Geophysical and remote sensing is important, and also a national database of geotechnical data. If we can have that, Hong Kong already has it, but Hong Kong is a very small country. If we can have something like that, then we should be able to get a little bit more understanding of the geotechnical properties of the soils and rock in India. When we talk about geotechnical constructions of the future, we're talking of modern piling rigs and big rigs for ground improvement. Of course, use of electronics, technology, and software to guide construction of piles. Warning signals if something is not going right. Technologies using more efficient rigs, and superior testing methods and quality assurance. So that's what we should see in the future, hopefully. With that, I close this presentation. Thank you very much.
Oh, he's not here. So I would like to call Professor Datta. Please. Maybe. So it's a small token of appreciation from us.